Ladies and gentlemen, good afternoon and a warm welcome to each and every one of you to day third of the 1 month certification course. With the blessing of Honorable Founder President Dr. Ashok Kumar Chauhan, Honorable Chancellor Dr. Atul Chauhan, and under the guidance of Vice Chancellor Ma'am Dr. Balbinder Shukla and the mentor of AIES, we AIES welcome all of you today at this beautiful afternoon. The certificate course on green technology for mitigation climate change from 31st August to 29 September in hybrid mode in collaboration with India Meteorological Department, IMD, New Delhi, and leads Nextech India Private Limited. The theme of our today's session is sustainable agriculture and green infrastructure. Sustainable agriculture and green infrastructure are two interconnected and the utmost issues that have gained significant attention in the recent years. Sustainable infrastructure systems are those that are planned, designed, constructed, operated, and decommissioned in a manner that ensures economic and financial, social, environmental, and institutional sustainability over the entire infrastructure lifecycle. Sustainable infrastructure can include built infrastructure, natural infrastructure, or hybrid infrastructure that contains element of both to achieve the sustainable development goal by 2030 and net zero emissions by 2050. Significant investment in sustainable and resilient infrastructure is required. So, sustainable agriculture is one which depletes neither the people nor the land. With these words, I look forward to an incredibly productive and enlightening session with all of you. So now the first speaker of our session is Dr. K. Karthikeyan. Dr. Karthikeyan is senior scientist in the field of soil science pedology. He obtained his PhD in soil science and agricultural chemistry from Indian Agricultural Research Institute, New Delhi. Thereafter, he joined an agriculture research service in January 2008 and posted in ICAR, National Bureau of Soil Survey and Land Use Planning, Nagpur, Maharashtra. He is actively involved in soil survey and mapping, basic pedological research, and soil carbon study. So published many research papers in international and national journals. Ladies and gentlemen, let us extend a warm virtual welcome to our esteemed speaker as we present this symbolic virtual Tulsi sapling from Dr. Renu Duper to signify the growth and nurturing of knowledge and wisdom in our virtual gathering today. Welcome, sir.
Welcome. Thank you. So the screen is visible now, ma'am?
Yes,
Can
sir.
you see the, now
Yes, sir, it's visible. Yes, sir.
full screen. Okay.
Yeah, sir.
Okay.
Yeah.
Thank you. Thank you, one and all, ma'am, for your kind words and introductions. And respected dignitaries of this program and the organizers, Dr. Jugi, Dr. Richa, Dr. Renu, and all. You have taken a lot more painstaking effort for conducting this program. So thank you. Thank you for all the organizers. And I feel proud to be part of this program. So for the next 1 hour, I will try to explain some of the important aspect of these sustainable agriculture productions. Because basically I am from an agriculture background and particularly related to the soil science. So my talk will be continuously related to the sustainability. The perspective of my view of the sustainability is through the soil, since the whole process of the agriculture rests on it. In the fast changing world, we have a task that to eliminate an hunger and to ensure the food security and the nutrition security as well, because soil you might be knowing that it is a nature's finite gift to a mankind and form the basic medium for the infinite sustenance of the plant and animal. Actually, this kind of words mostly people will refer to the great philosophers and other kind of peoples, but this is the words which always our teacher from my PhD, he always tells these things. So I refer my teacher words that soil is a nature's finite gift to the mankind and forms the basic medium for the infinite sustenance of the plant and animal and people as well. But how the soil is most important? Because majority of the food, that is more than 95%, is from the soils and nutrients to the plant, except few. Out of 18 essential elements, 15 has been supplied by the soils. And by 2050, we have to increase our production by 60% to meet the global food demand. And there is a report from the FAO that out of 60% increase the food production, which we are targeting, the 58% of the food could be produced through the sustainable management. In between, we are losing 35% of the soil by the process of degradation, which is already we are going to lose in the future, in future. So the whole process is due to the ever increasing populations. If you see the number of people living the worldwide since 1700 in billions, the first doubling of the population which has been occurred in between 123 years. For doubling of a population from 1 billion to 2 billion, it takes more than 123 years. And the next addition has been made within 33 years. And subsequently, in every 12 to 14 years, we are getting in one additional billion. In the last 50 years, we can see the increase of 3 billion of populations, that is specifically from the two continents, that is Asia and Africa. So these populations necessitate for this sustainable development so that we can tackle the 60% of the food grains and we can make the population hunger free in future. So if you see the land use scenario of the Indian agriculture, and we can see the per capita land availability, which has been from 2020 to 2050, it is getting reduced. And the net sown area is static. And with this net sown area only, we have to produce the 60% of more food production in the targeted 2050. And the water use efficient, the water for irrigations has to be increased. When the water used for the irrigation is increased, the salt affected of the soil is going to increase. When the salt affected soil is getting increased, the production will getting automatically, it will get decreased. So this is the overall scenario of the Indian agriculture. And if you see the vision document of the 2050, which is given by the Niti Aayog, which has, these are all the projected demands. And most of these projected demands shows that the 60% of food grains is very much essential to feed the burgeoning populations. And as a gist, if you see in India, we are going to be reaching 1.7 billion populations in 2050, for which we should need 1.4 times of the increased food productions and 2.2 times increase in pulses, and same for the fruits and vegetables, and 1.7 for the sugar canes and other things. So to tackle all these projections, we have to manage the soils and the soil properly and make it more sustainable, which has been clearly spelled out in the Sustainable Development Goal of the UN SDGs, so that the degraded soils and the improve the soil health to make the sustainable. So there comes the sustainable soil management. So to make the system sustainable and productive, we are adopting this sustainable soil management system. It is a balance. The soil sustainable management system is the balance between the support and the provisioning services for plant productions and regulating services, the soil provides for the water quality and availability for the atmospheric greenhouse gas composition is in a particular. And for maintaining the soil, sustainable soil management, there are general criteria, characteristic features which we have to follow to make the agriculture productions more sustainable. That is, first is this minimal rate of erosion. If you see the erosion, for every 5 to 10 seconds, we are losing one football ground, that is a one football soccer ground, that 15 centimeter of the soccer ground soils we are going to lose. So if we adapt this sustainable soil management system, we will minimize the soil erosion, and the soil structure will be maintained. When the soil is covered by the plant, the soil structure will be maintained. And if it is sufficiently the surface cover has been maintained, we will avoid the unwanted weed growth and the increased soil organic carbon as well, and the nutrient flow will be proper. And when the nutrient flow is the proper, soil salinization, salinization and sodification, alkalinizations will be get minimal. And with this minimal of these salinization sodifications, we are attaining the sustainable development goal in 2030 at the earliest, as per the Delhi declarations. And water and using the water efficiently. So these are all some basic characteristics of the sustainable soil management practices. And these sustainable soil management practices, with these sustainable soil management practices, we are adopting some conservation practices by which these principles, which are all mentioned in the sustainable soil management practices, will governed by that, by which the conservation agriculture has been practiced, in which the three pillars, which is much important things which governs the conservation agriculture, that is the minimal or no tillage or permanent cover or the plant diversity. By maintaining these three pillars, the conservation agriculture makes the carbon positive budget, in which the soil carbon sequestration will be more than the soil carbon depletions. So in this conservation agriculture practices, as we mentioned in the three principles, the continuous minimal mechanical soil disturbances and reduced tillage is the first and foremost principles. And the second principle is the permanent soil cover. And the main motto of the permanent soil cover is to keep the soil surface covered around the year, so that the erosion and the soil degradation, everything will get delayed. And diversification of crop rotations, and preferably inclusion of the legume crops in this in case of annual, and perennial crops in case of the association crops. So in this is the basic principles of these conservation agricultures. In this just by this application of these conservation practices, the root growth has been seen in the conventional tillages, whereas the internet is getting detected. It is getting reduced. So by applying these conservation tillages, we can able to control the soil erosions, and by controlling the soil erosions, we can save the soils. And by controlling these surface, the covering of this soil surface, we can avoid the overflow, runoff, and improve soil filtration. And soil rotation will maintain the soil structures, which result in the soil infiltration rate. And if you see, by applying this conservation agriculture, the restricted root growth. There are two comparisons which we have made with the conventional agriculture and the conservation agriculture. If you see in the conventional agriculture, below the plow pan, the root layer is getting restricted. Whereas in the conservation agriculture, there is an extensive root growth down the soil profile has been seen. So as the root grows down, the rhizosphere is getting enhanced and it will be getting a good biodiversity in the rhizosphere. So it will get a good absorption of the nutrients in the in rhizosphere regions for the plant. So, and subsequently, it will maintain the aggregated soils. If the soil is get aggregated, the infiltration rate will be more. Whereas in the conventional agriculture, the aggregation will be getting breakdown, so the soil runoff will be more, and due to the runoff, the erosion will be more. So this erosion will be controlled by these conservation agricultures. And currently, the emission of carbon dioxide is one of the major factors for controlling the climate changes. So in agriculture, carbon dioxide emission is one of the major factors. It has to be controlled. By conservation agricultures, we are maintaining the crop residues which are left by harvesting, so that the carbon dioxide emission to the atmosphere has been controlled. And by this, one of the practices, the burning of the residues will also be is already controlled, and additional residues in the surfaces increases the soil organic carbon, and these soil organic carbon will increase the non-labile carbon content of these soils. So the carbon dioxide emissions will be controlled by these conservation agricultures. And altogether, there is a nutrient dynamics. When you see the nutrient dynamics in conservation agriculture, will be having the more nutrient retention when compared to the conventional agriculture. In a conventional agriculture, there is a lot of nutrient leaching will be there. When there is more tillage will be there will be a more nutrient leaching will be there, and resulted in the groundwater pollution, Whereas in conservation tillage, there will be an healthy rhizosphere by the healthy biodiversities which has been created due to the soil cover, and due to which the nutrient retention is more in the conservation tillage. An experiment conducted in the ICR with the various technologies of the conservation agriculture, we can able to see there is all the conservation practices has been tested in the different conservation practices are giving in different level of productivity and different profitability. In some technology is giving effective productivity, and some is giving the profitability, and some is giving water saving, and some is giving the less greenhouse gas emission. If you see these zero tillage and residues will have the less greenhouse gas emission. And whereas for profitability, if you see the crop diversification give the maximum amount of crop diversifications, and for subsurface drip will give the maximum water saving capacity, and for productivity, there is the CSA package will give the maximum productivity. And these all the technologies comes under this conservation tillage. So all the technologies which are all adopted in this conservation tillages are give one or otherwise it is productivity, profitability, and water saving, and greenhouse gas and reduced greenhouse gas emissions. And even though we are having many problems in adopting the conservation agricultures, like there is an optimum or effective herbicide has not been advised for this conservation agriculture. This is one of the problems which are all mentioned in the conservation agriculture. And the people mindset is also one of these things, lack of awareness. These are all the main things which prevents for the adoption of the conservation agriculture. But we have to overcome all these kind of things to make the agriculture more prosperous by making the soil more sustainable. And conservation agriculture can be called as the future of the agriculture. Without maintaining of the soil, the sustainability cannot be existed. So conservation agriculture is the one of the promising factors. For this, the government should formulate a policy for the farmer to provide incentives at the initial level, because initially whatever the package and practices you are going to adopt, that will not yield as better as the conventional agriculture, because everything, the yield will be reduced initially. So yeah, for that, the government has to make a well managed subsidy or insurance for the adoption of well-defined good agriculture practices, which enhance the sustainable soil management systems. And government is formulating many schemes to take the nutrient deficiency, since it affects directly the crop productivity. If you see all over India, the maximum area is deficient on the major nutrients. And recently, after the green revolutions, you can see the micronutrients and secondary nutrients is also getting deficient. So these are all the recent pictures, which more than 50% of the area is deficient in our country. So government is planning for new schemes. So why they are planning for this new scheme? Because of these declining partial factor productivity and declining the organic status and emerging nutrient deficiencies. And these are all the major criteria for which the government is coming with the new schemes. And government has planned for the national soil health policies. And in this, promoting integrated nutrient management through soil test-based balanced use of nutrients in conjunction with organic manure, and strengthening the soil testing facilities and soil test-based recommendation to the farmers, and promote use of soil amendments for reclamation of acid and alkaline soils, and to support the various types of soil and land resources survey for creating a comprehensive database. And based on this, a comprehensive soil health card scheme has been developed, and it has been launched in 2015 under this present government. And by this, there are more than 17 to 18 crore of soil health card has been issued. And but the basic thing which we want to know in this soil health card is that the soil has the two different properties. One is inherent properties and another is a dynamic property. Inherent properties are generally will be formed along with the soil forming processes. That is the with the link of the climate, organism, relief, parent material, and topography. So some of these inherent properties are texture, structure, and the clay minerals. These are all the type of the soils. These are all the inherent property which cannot be changed. And these dynamic properties, that are all surfacial properties, which are all managed due to the management practices. And these dynamic properties will change regularly in every cropping seasons, whereas the inherent property will not change in every cropping season. It will be static. It is not. Inherent properties are static, and dynamic properties are very dynamic in nature, as the name says. But in the soil health card system, soil health card, we are taking the top 15 to 30 centimeter soil. Most of them are dynamic in natures, and based on these dynamic natures, we are deciding our nutrient calculations, and accordingly the fertilizers has been recommended. And the revisiting of the soil health card scheme is after 3 years or 5 years, but you are getting change in every season. So this is one of the lacuna in the soil health card system. But whereas if you compare with this inherent property also along with the dynamic property, that will cost more, but it will have the result is more appropriate, and it will be directly linked to the production systems. If you see, this is a profile. Normally we will study a profile up to 150 centimeters. In a top topsoils, the soil will be grow up to these 15 centimeter. This 15 centimeter of the soil, this is called as flow layer. In this area, the sampling in these areas only we are taking and preparing the soil health cards, and we are making the fertilizer recommendation as well. But there is a small analogy that whenever we will not having money in our pocket, we will take the money from the bank. That is the general tendency all people will be having. So the top layer, that 15 centimeter of this soil is getting exhausted. It has been taken by the plant. Then this layer will be completely depleted. So the bank is this area. So in this area, the equilibrium will be maintained. So this area, the soil, the nutrient will be transferred to this area so that the equilibrium will be maintained to the soils. So, taking the top, studying the top layer of soil is not that much productive. That what we have been identifying in the research, that we have taken all through that Maharashtra, we have taken a study that we have taken a 0 to 50 centimeter of the soil and 0 to 100 centimeter of soil. Why we have taken 100 centimeter soil? The 100 centimeter soil is called as the soil moisture regime. Soil moisture means soil control section. Whenever the control section is there, soil control section is top to 0 to 100 centimeter of the soil. That is called soil control sections. In these soil control sections, whenever the top layer of the soil is get depleted, the nutrient from the bottom layer, that the subsurface layer, will be come to the surface layer, and it will be contribute to the crop growth and development. So we have analyzed this kind of study with the 15% and 100 centimeter. We can have a very good relationship between with the crop yield. If you can see all these major soils of Maharashtra, this whatever the research we have done, everything has been done in the black soil regions. In 0 to 50 centimeter, you can see the R square value of 58. And if you see that 100 centimeter of soils, this is 82. That is that much of relations it is directly had with this productivity. So all the soils 63, 80, 56, 85, and it has been published in a well-reputed journal, international journal. So the main thing is that the soil control section has to be taken. Soil control section has to be taken in any soil management practices, so that it will make the system more sustainable. And currently our NBSS LUP, NB National Bureau of Soil Survey and Land Use Planning, our institute is entering into the land resource inventory for sustainable agriculture. And what is this land resource inventory? This land resource, whenever we are doing any agriculture practices, we should have a basic information or baseline data. So whenever you are going to a doctor, so you should know what is the present situation. Then only you can tell to the doctor, and doctor will recommend all kind of things, so that you can come with the you can improve your health. Similarly, so we should have a base data where you are. That base data has to be collected at each and every parcel of the land. That is the land resource inventory. Without that base data, whatever the things which we are doing without the base data. So the government has came with a plan that wherever the policy or program is getting implemented, there we should have a baseline information. That baseline information is now implemented by the government of India, by different agencies, the Department of Land Resources and Watershed Management, so on and so forth. And this is currently this is the prerequisite for all these government projects. That is land resource inventory for sustainable agriculture, so that by implementing these land resources, we can overcome the degradation and the deterioration of resources, and we can improve the factor productivity and restore by the management interventions, by site-specific technologies. So all these site-specific, all the information, farm level information, in Hindi they will Kasara number informations. All Kasara number informations will be generated by this land resource inventory. And this land resource inventory, after developing this land resource inventory, it will address the scientific land use planning, and so that the reclamation and diagnosis of the soil problem will be appropriate, and judicious use of fertilizers and irrigation of water, and identifying this micronutrient and make the soil healthy, and we can improve the productivity. And now this kind of land resource inventory has been made a compulsory in this recent guideline. There is a program called Pradhan Mantri Krishi Sinchai Yojana. In this Pradhan Mantri Krishi Sinchai Yojana 2.0, government has insisted that wherever the government programs and plannings are to be implemented, that area has to be built. You have to build a land resource inventory first, and with that land resource inventory only we can go for the further program implementation. Because in for an early development project, government is targeting in a watershed basis. So the major this LRI is watershed basis implementation has been done by the Department of Land Resources, and the implementation agency is the National Bureau of Soil Survey. So ultimately the baseline data will be developed, and with this baseline data, what has to be done in future, how the planning has to be done, what is the plan, and what type of practices has to be followed, that kind of things has to be conveyed to the farmer. Not every parcel of the land will be assessed and it will be done, and this kind of practice is much more benefit than the soil health card. Now we are moving ahead of the soil health card, and whatever the information which we have got from the soil health card, with that information we are moving away ahead of that information. So ahead of that information, and make this system more viable. And this LRI is important for PMKWS, that is Pradhan Mantri Krishi Sinchai Yojana, because watershed department is the priority focus on the optimum and sustainable utilization of the soil. Because whenever we are going for state level plan, district level plan, block level plan, these kind of plans are getting mostly this level of planning are not getting that much of yield. So they are going for watershed based of development, because in watershed based of development is the most appropriate way of development which the government thought of. So we are going for LRI, and the LRI is an appraisal for this available. Whatever the present situation is there, that is directly reflected by the land resource inventory informations. And with these informations, all these socioeconomic data, forests, livestock, and humans, everything will be comes into picture. So integration of all these things, the land use plan will be developed. So that is the way that this Pradhan Mantri Krishi Sinchai Yojana is thought of, and now it has been targeted that India in 10% of the area has to be covered by these 2 to 3 years, and sequentially it has to be raised up, and it has to be covered, it has to reach to 50%, so that by 2050 it has to be the whole India, the whole country has to be covered under this land resource inventory. This kind of study will help what kind of soil and how much extent are there, and based on that study we can know the soil related constraints, and if we know the soil related constraint, we can utilize the potentials of the particular soils, and based on that we can develop an optimum agricultural land use plan. And with that agriculture plan, we can also assist and making decision on land use for the different targeted groups, because same decision will not be suited for all the farmers. Different set of people, farmers will have different set of needs. So accordingly, based upon the farmers' needs, the advisory will be given, and used for planning, monitoring, reviewing, evaluating. All the land-based development projects will be done based upon this output. The project output would be help to monitor and manage and sensitive ecological zone. If you have all the baseline informations throughout the country, you can easily monitor by sitting in a place, and you can give the recommendations, and you can develop the crop plan accordingly. And finally, a land use policy of the state or land use policy of the country will be developed, which the government is looking for. So still now we don't have that land use policy, and finally we are going to develop that land use policy. And this land resource inventory will make the farmers and communities more independent and more they are empowered. So LRA output help in sensitizing the issue to the farmers, and based on which the land suitability map, the crop selection will be done, and based upon the crop selections, the farmers will get the best returns. And based on for these crops, site-specific nutrient management will be given, because we are having a plot-wise information. So based on the plot-wise information, we are giving the site-specific nutrient management instead of the per plot nutrient management practices. And this will be the output. So in a block, this is a watershed. In this watershed, there is a different types of soils. You can see different types of soils. There are different colors or different types of soils. It's based upon these soils. These are all the broad classification of the soils. In this block, you can see 7 to 8 types of soil series are there in this soil series, and further it will be based upon the slopes, based upon the texture, slopes, erosion, graveliness, and depth. Each sector will be, again, it will be subdivided. So such a minute information will be taken under this land resource inventory. And for this inventory, we will develop a thematic maps. Thematic map means for soil conservation, for soil erosion, and for different crops, for suitability maps, rice, where rice can be grown, where wheat can be grown, where soybean can be grown. Like that, we will have a different crops, and based upon these maps, the crop colonies and crop productions will be decided. And this land resource inventory, which has been implemented by this DOLR, and it has been taken by the National Bureau of Soil Survey, which has also got the Prime Minister Award for the public administration in the innovation category for the scientific soil and water conservations for sustainable farming. And this has been given for the Karnataka government, and which we have done this works. So finally, it is the soil going to feed you. It is not the oil that will feed the world and controls the environmental quality. Without soil, there would be no life. Without soil, there would be no oil. And without soil, there will be no sustainability. And from the words of the Henry Link, I may conclude my presentations. Thank you. Thank you for your patience. And thank you.
Thank you, sir. Thank you so much. We want to express our heartfelt gratitude for the incredibly enlightening session on this topic. So we have received some questions in the chat box.
Yes, sure.
Yes, sir. The question is, what barriers exist to implementing long-range investments in sustainable agriculture?
What barriers exist to implement long-range investment in sustainable? Actually, barriers exist means directly it is the production. Whenever we are going for a sustainable agriculture, initially there will be the production constraint will be there. Immediately, as soon as whenever you are going for an advanced level of farming, you will get whatever you will putting, you will be getting input and output will be more than input will be output is equivalent to that. When you are go for conservation agriculture and the soil management practices, the production will be for getting that kind of production, the production will be take time to get sustainable. The production level, the time limit, you have to take care of the time limit, because for every input, extensive agriculture, you will be getting more production in extensive agriculture. But for conservation agriculture, there will be a time lag will be there. For getting that kind of yield, you have to wait for 5 to 6 years time you have to get. Then the production will be get sustainable. So that time is the major issue, and money is other thing. So these are all the two things that we have to take care of. Then after that, the things will get sustainable.
Okay, sir. Thank you, sir. The next question is, sir, what is the ROI, return on investment, for long range investments compared to short term agriculture practices?
Actually, whenever we are talking about the sustainable management system, we have to talk about the long range. It's not a short term. Whenever we're going for short term, we are getting that maximum productions, maximum input, maximum productions, and ultimately your soil will be getting deteriorated. And now it is this much of development which is going in the government side also. And 1.7 lakh crores has been invested every year for maintaining the soil resources alone. And this is not only, this is only for this land resource inventory for getting the base data. And there are rural development ministry which is investing more than 4 lakh crores. Everything altogether is invested just to maintain the soil in a proper way. So this kind of investment is going on. So to make anything to be made sustainable, we have to look for a long range rather than the short range vision.
Thank you, sir. Thank you so much, sir, for such a brief explanation, sir.
Thank you.
Thank you, sir. Karthikeyan sir, I would like to point it out that we would like to congratulate for all the publications that you have done. The work was really good.
Thank you.
Which led to, yeah, sir.
Mm.
That was really nice. Richa, do we have any other question?
No, ma'am.
Okay. Okay, then let's proceed further.
Yes,
Thank
ma'am.
you so much, sir. Thank you so much, sir, for
Okay.
joining.
Okay, thank you.
There must be a better way to make the things we want, a way that doesn't spoil the sky or the rain or the lake. With these words, I welcome the second speaker of our session, is Dr. Amar Kumar Kathwas. Sir is an agriculture specialist with 8 years of experience and proficient in remote sensing applications in climate resilience agriculture. Sir has written several research articles contributing towards scientific research. He believes in providing resilience and feasible solutions to take hold of climate, water, soil hazards, and landscape dynamics influencing soil and crop productivity. He majored in agricultural science at Allahabad Agricultural University. He had his master's in geoinformatics from Birla Institute of Technology and also pursued his multimodal doctoral research on soil erosion, encompassing impact and influence on crop production, landscape, geomorphology, demography, and dynamics from the same university in 2019. He joined Haryana Space Application Center as research associate in 2020 and worked on crop computation and yield estimation. In the third quarter of 2022, he got associated with Leeds Group as Senior Agriculture Remote Sensing Specialist. Welcome, sir. Sir, we welcome you with a virtual Tulsi sapling from Dr. Juhi Gupta. Welcome, sir.
Am I audible, ma'am?
Very welcome, sir. Yes, sir. Yes, sir, you
Yes,
are.
yes, sir.
So I
Thank
would
you
like
for
to thank,
joining, sir.
thank you, ma'am. Thank you, ma'am. So foremost, I would like to thank all the organizers and MIT Institute of Environmental Sciences for providing me the opportunity. And let's go for the presentation. So
Yes, sir.
is my screen visible to me?
Yes, sir. It is.
Okay. So I am here to speak on the topic that is space tech based climate resilient agriculture. So coming to the first part, that is what is climate? The climate can be defined as the prevalence of average weather conditions over a long period for a particular location. And the occurrence of long-term shift in the weather pattern is referred to as climate change. These changes can be induced due to the natural phenomena or due to human activity. The climate change is referred to as a threat since it is directly impacting the food production and food security. The process of cultivating commodities for the production of food, fiber, livestock, and allied services is mainly defined as agriculture. The climate resilient agriculture are practices for increasing the productivity and reducing the vulnerability towards climate change. So here we can see that there are basically two main causes of climate change, that is natural and anthropogenically induced. The natural events that lead to climate change phenomena are continental drift, volcanic activity, shift in the earth tilt, ocean currents, and advancement in incoming solar radiation from the sun. These events takes time and don't occur suddenly, whereas the anthropogenic activities such as intense and unplanned landscape conversion involving deforestation, urbanization, and emission from industries and vehicles releases large amount of greenhouse gases such as carbon dioxide, methane, nitrous oxide, which are ultimately get trapped into the atmosphere of the earth and heat up the atmosphere. Also, the gases such as chlorofluorocarbon are resulting in the depletion of the ozone layer, which ultimately leads to the atmospheric warming. So what are the effects of the climate change? Largely, the effects of climate change can be categorized into mainly 6 classes. That is global warming, occurrence of extreme weather events, loss of agriculture, rise in sea levels, scarcity of water, increase in occurrence of disaster management events such as floods, landslides, drought, and etc. Due to these climate change events, the occurrence of various diseases also occur and has increased in the current time period. Moreover, the phenomena such as acidification of oceans, heat waves, urban flooding, migration of marine fauna, and melting of glaciers has also increased too. So the effects, coming to the effects of climate change on water, there is a significant impact. So according to the National Oceanic and Atmospheric Agency of the US, the global sea level and the global temperature of the sea and oceans has witnessed an approximate 0.13 degrees Celsius increase in the past 100 years, and rise in the organic content, that is dissolved organic carbon, which is basically organic compound that passes through 0.45 and 0.47 filter and is carbonaceous in nature of is carbonaceous component of organic matter comprising dissolved nitrogen and dissolved phosphorus. Due to the absorption of CO2, the pH of the ocean is decreasing, and which leads to the acidification. Currently, the pH is around 8.1, and which is expected to be reduced to 7.91 by 2020 by 2100 year. And since there exists an inverse relationship between the dissolved oxygen and in temperature, with rise in the temperature, a decrease in the dissolved oxygen in water is observed and affecting the marine life. And coming to the impact of climate change on soil, due to the rise in the temperature of enzyme activity, the enzyme activity in soil tends to decrease due to denaturation. And these enzymes transform the organic matter into nutrients for plants. An increase in the soil temperature is observed in studies conducted by researchers all around the world, and is revealed that at all depths, the soil temperature has risen by approximately 0.5 to 1 degree Celsius, both at the warm and the cold periods. Due to the climate change, evaporation rate has increased, reducing the surface water reduction, leading to vegetation dryness and increased water demand. Due to the climate change intensity and frequency of degradation process, as erosion, runoff and leaching increased, leading to nutrient loss. Adopting practices such as crop rotation, cultivation of coverage crops, mulching and precision farming and nutrient management can improve soil health significantly. So coming to the impact of climate change on socio-economic conditions, similar to the soil and water, it has largely impacted the social economy also. In terms of food demand, farmers' response, policy making, trade and cost of commodities. Due to the climate change and changes in the air quality status, various diseases related to lungs, heart have become more prevalent, and also the insect-borne diseases. Moreover, the migration of people to urban center is also observed due to the climate change. So, impact of climate change on agriculture can be seen as the intense and can be seen in various fields, and it comprises the wildfires due to the high temperature leading to the loss of crop and organic matter. And the climate change also leads to the increase in the soil pH, which impairs the plant growth and subsequent loss of productivity, water scarcity and livestock health. Occurrence of natural catastrophic events such as floods and drought along with erosion tends to degrade land quality, and introduction of various pests and diseases are also introduced to the crops, and yield loss is observed. So these are some of the climate influence parameters affecting the crop, and where we can see that the weather parameters such as rainfall, temperature and humidity are basically the main weather parameters. And second, the management parameters that such as crop rotation, degradation of soil and irrigation timing is also affected. Practices comprising conservation practices such as zero-till seed drill and variable rate technology are affected. Apart from that, the rate of erosion and occurrence of waterlogging due to the incandescent rainfall events, droughts, and phenological and morphological parameters of plants such as chlorophyll content in the leaves, their orientation and tillering are some of the parameters that are significantly influenced by climate change. So there are positive and negative effects of the climate change. The negative effects of climate change include crop damage, unreliable weather forecast related to the planning of crop sowing, an increase in drought, weed growth, moisture stress, and crop diseases. Occurrence of intense storms and flood events causing loss of property, human life, and economy, and increase in the rate of soil erosion process leading to the land degradation of croplands and vegetated areas, and increase in the human labor sickness. Apart from that, climate change has also some positive effects such as increase in the productivity, but at the cost of lower nutritional value. and the warmer and longer seasons provide conditions suitable for the introduction of new crops in the region, and with low water requirements, and the time taken for crops to mature is also reduced. And the crops which can be introduced in these areas are like millets and all. So why is climate resilient agriculture important? Since climate resilient agriculture comprises adequate measures and practices for ensuring food security and sustainable development of resources such as soil and water, it is crucial during the changing climate scenarios. Farmers can adopt climate resilient practices such as rainwater harvesting, crop diversification, and adapt to the climate change by growing climate resilient crops. Basically, adopting climate resilient agriculture measure is essential for food security and sustainability of the environment and the human being. So what are the solutions for climate resilient agriculture? It comprises basically the efforts from the government and the people. And here we can see the increase in weather analysis is one of the solution for the climate resilient agriculture, along with the development of site-specific climate predictive models. And based on the agroclimatic conditions under the National Agriculture Research Project, ICR has categorized the country under the 125-6 agroecological zones. Based on that, we can use the various modeling approach for adopting the crops for the certain zones, and use of precision and smart farming techniques such as variable rate technology for fertilization and for use of sensors for monitoring pest and disease. Practices of crop rotation, cover crops, mulching significantly improve the nutrient availability, moisture level, and organic matter status of the soil. And government can also provide agrometeorological advisory at block level and district level, and can provide more training and technical guidance regarding the latest technology in agriculture for sustainable development. So climate resilient practices not only involves the agriculture practices, but also involves the practices in the fields of forestry, greenhouse gases, and all. So here we can see that the climate resilient agriculture practices in agriculture mainly comprises the introduction includes higher production, farmers' income, and food security. Whereas in case of the greenhouse gases, practices such as adoption of green energy, efficient crop and livestock management is required. Moreover, plantation in the form of agroforestry and social forestry can be practiced, ensuring the forest resilience. In case of landscape, adopting measures to reduce land cover dynamics to a sustainable extent, and in case of water, increase in storage, decrease in wastage management of watersheds and river is required. So challenges of climate resilient agriculture. So there exist significant challenges in the climate resilient agriculture in countries like India. Primarily, the main challenge is lack of knowledge, and the farmers' adaptation is not homogeneous but varies with changes in the agroecological region. Implementing and prioritizing the practices is also a significant challenge, as no climate sustainable agriculture techniques offers a solution to foregoing challenges. Lack of understanding regarding the climate resilient agriculture practices is also required. Coming to the space tech, it is basically composition of three main pillars, that is the remote sensing, GIS, and GPS. So the first pillar is remote sensing, and it can be defined as the art and science of collecting information about the surface of Earth without coming in direct contact. And the information gathered with the help of various sensors and the cameras attached to the satellites and the aircraft. Some of these remote sensing sensors that collect the data are Landsat of the USA, Spot of the France, Sentinel of the European Space Agency, and the Indian remote sensing satellites of the India. As we can see in the figure to the right, that the emitted energy from the sun or the satellite after getting reflected by the Earth's surface is observed by the sensors, and the data collected is then transferred to the control stations, and interpretation and analysis are done further. So the satellites basically operate with the help of the electromagnetic energy, and the electromagnetic energy of the sun is basically the vibration produced by the charged particles that have different wavelength and frequencies. Some of it get absorbed and some get reflected by gaseous molecules present in the atmosphere, while some pass through the unimpeded movement. A very small portion of electromagnetic energy is can be observed by the human eye, and the energy reaching the surface of the earth gets absorbed or reflected is totally dependent on the composition, albedo, and roughness of the surface. For example, snow has a very high albedo and reflects 90% of the energy that is received, while in case of oceans, it reflects only 6% of the total energy received. In remote sensing, basically two types of sensors exist. That is, first one is the active and second one is passive. So the active sensors are those which operate with the help of their own source of emission, and they operate mainly in the microwave region of the electromagnetic spectrum, and these sensors are immune to the weather conditions. Whereas the passive sensors, these are those which rely on the sun as a source of illumination and operates in the visible and near infrared region of the electromagnetic spectrum. And these are basically called as multispectral or hyperspectral sensors and are not immune to weather conditions. So in field of remote sensing, the capability of satellite or a sensor can be defined based on the resolution of the sensor. And there are basically four types of resolution. The first one is a spatial resolution, which can be defined as the ability of the sensor to distinguish the smallest available object, and it is also known as the instantaneous field of view of the sensor. Whereas the spectral resolution is the resolution of the sensor in the electromagnetic spectrum range in which the sensor collect the data. The multispectral sensors basically have very few spectral bands which are basically very broad, while the hyperspectral sensors have hundreds of bands, and each bands are very narrow, spectrally very narrow. Coming to the radiometric resolution, it is the capability of the sensor to differentiate the values in grayscale and is measured in bits, and mathematically it can be represented, the computation of bits can be done by the formula 2 to the power n, where n represents the number of bits. For example, the Sentinel-2 multispectral data provides the data set in a 12-bit imagery, and which comes to approximately 4096 values, which means that the sensor can discriminate 4096 values in the grayscale. Whereas in the case of the Landsat, it provides the data set into 8-bit imageries and can discriminate up to 256 gray values only. And the last one is the temporal resolution, which is simply the revisit time of the satellite to the same location. So coming to the role of remote sensing in agriculture, it basically extends the role of remote sensing in agriculture is very wide and extends from acreage estimation to yield estimation and nutrient deficiency detection, assessment of organic content, moisture levels, pest and disease infestation determination, land suitability and degradational analysis, drought and stress detection, monitoring land use land cover dynamics, biomass evaluation, determining agroecological zones, irrigation timing, disaster management, and development of mitigation measures and supply chain management of agriculture and other commodities. So how does remote sensing basically works? So here, for example, we can see that in plants, the energy in the blue and red region has the energy in the blue and red region is very low due to the absorption by the chlorophyll present in the plants leaves, and the wavelength in the while the reflectance of energy in the green wavelength of electromagnetic spectrum is slightly high, which results in the green color appearance of the plants. And similarly, the energy in the NIR region of the electromagnetic spectrum, it is very strongly reflected, and the plants are from the plant surface, due to which the it is due to the leaf cellular structure. Here in the figure, we can see that the reflectance of electromagnetic energy in the blue and red is significantly low compared to the green spectral range, whereas the reflectance in the NIR region is significantly high. These properties are used for the generation of various spectral indices such as normalized difference vegetation index, normalized difference built-up index, snow index, and water index. Moreover, the figure in the upper right depicts that the spectral curve of healthy green leaves and the yellow leaf. And here we can see that the yellow leaf reflectance is significantly low in the blue, green, and red region of the electromagnetic spectrum as compared to the green leaf. And furthermore, the spectral curve of various plant pigments such as anthocyanin, carotenoids, and chlorophyll A and B, and water molecules is depicted in figure to the lower end of the lower right figure of the page. So the second pillar of the space tech is the geographical information system, and it is basically the spatial system for the creation, management, storage, analysis, and mapping of any sort of data related to Earth, be it demography or the air quality. And here we can see basically that there exists two type of data set in the GIS environment. First one is the raster data set, and second is the vector data set. So the raster data sets are basically the data set which are in the form of pixels, and where each pixel represent a specific location, and whereas the vector data set can be categorized into three classes, that is point, line, and polygon, and is useful for storing and representing data that have discrete boundaries such as buildings, streets, and land covers. And when these data sets are prepared and specific attributes are assigned to the features, and we integrate all the layers in a GIS environment, and the composition and the composite depiction is made in the context of location is depicted in the figure to the right. What is resembles to the when we composite all the layers produced in the GIS environment. So basically the GIS process starts with defining the problem, followed by outlining important criteria responsible for the problem, and further the layers and data sets are prepared in GIS environment and or imported from the other sources such as remote sensing sensors or the tertiary sources. And in the next part, the data sets are analyzed using GIS operations or spatial or mathematical models, and output is generated. And these output, and then the generated output is used for the assessment and carrying out the decision-making process. So in today's time, the GIS is used in every field for solving all sorts of problems. And the use case extends from problem identification to monitoring and change detection, forecast analysis, pattern distribution, trend analysis, prioritization, and carrying out management practices. And the third pillar of the space tech is basically the global positioning system, that is GPS, which is primarily used for gathering precise location of an object on the surface of the Earth. On the whole space tech has several advantages, such as increase in the efficiency and reduce cost. However, there exist certain challenges such as cost, access to technology, and storage and management of data set. So coming to the role of the remote sensing in climate resilient agriculture, the multispectral and hyperspectral imageries of the imageries can be used for early detection of disease and pest infestation, and for the precise control measurement adoption. And the thermal and microwave data remote sensing data sets can be used for assessment of temperature and water status of soil and air, and for also irrigation optimization. Use of spectral indices from using the multispectral and hyperspectral data sets are vital for the nutrient deficiency assessment and development of nutritional programs with minimal impact on the environment. And multispectral and hyperspectral imageries along with various crop models can also be used for the acreage and yield estimation, crop health management, and estimating harvest time for higher quality crops. Moreover, it can also be used in determining sowing time, weather assessment, forecasting, and events, and determining of the events such as drought and all floods, etc. Also, it can be used for suitability and degradational analysis. So there are various studies, and here is one of the study where performed in the Vietnam to monitor the stress areas in rice crops with the help of satellite imageries and ground-based sensors. The regions with water stress were determined by the researchers, and necessary recommendations were suggested to the farmers. And the farmers adopted the recommendations, and which resulted in the increase in the paddy yield up to 30% and reduction in the water usage by 20%. Moreover, the remote sensing techniques were also used for precise fertilization and pesticide application, which significantly reduced the impact on the environment. In the second case study, remote sensing was used to monitor and assess the animal health and productivity, where the researchers used thermal imaging to detect the early signs of the illness in cattle, allowing them to provide necessary medical assistance and resist the spread of disease in the cattle, resulting in the increased productivity. And in the another study, researchers use GPS collars to determine the grazing pattern of the livestock, which help them in smart decision making and regarding the management of pastures, and increase in overall productivity by efficiently using the available resources. And in the third case study done by the US Forest Services, space tech was basically used for monitoring the health of trees and prevention of forest fire by determining the areas affected by meteorological drought, and with large amount of and the area which have large amount of fuel woods, and where the forest rangers take necessary measures, and the risk of the fire was significantly reduced by higher extent. So in conclusion, the remote sensing has the potential to revolutionize the agriculture by helping farmers to adapt climate challenges. And moreover, remote sensing technologies such as drones coupled with ground-based observation, crop health, yield, and stress areas can be determined. And information gathered with the help of remote sensing can also be used to implement climate resilient practices. And I would like to mention that we at Nextech are performing Bayesian AI-based impact studies in 16 states of India, comprising Uttarakhand, Jammu Kashmir, Telangana, Kerala, Jharkhand, West Bengal, and 7 sister states, which primarily focus on the climate-centric sustainable development goals. And the findings is getting published, and the composite findings will be published in the book form by the Nextech publication house. So I would like to conclude here with the presentation.
Thank you, sir. Sir, we would like to extend our deep appreciation for the exceptionally enlightening session on this subject.
Thank you very much.
Sir, there are a few questions from our participants.
Yes, ma'am.
Yeah. Sir, first question is, what are the economic and policy incentives that can encourage farmers and landowners to adopt sustainable soil management practices? And what are the potential barriers to their implementation?
And basically, the government can initiate the training and training sessions and providing the latest technology which are used in agriculture for the sustainable development and increase the productivity and the income of the farmers, basically. And the barriers which are basically lack of knowledge and availability of resources, and the proper education system is also one of the barrier for the agriculture resources.
Yes, sir. Yes, sir. Moving ahead, sir, the second question is, are there crops that are more resilient to climate change than others?
Ma'am, crops such as millets, that is fox millet, barley, jowar, bajra, these are resistant to climate changes because these crops grow much better in the warmer climatic conditions, and therefore it is assessed that the in the product millets and the product yield might increase in the warmer condition and in the climate change conditions where the warmer climate condition is evolved.
Yes, sir. Sir, the third question is, which is the better way to choose land use and land cover classification data on different types of crops for Indian region?
Ma'am, basically there are various classification methods such as maximum likelihood, spectral angle mapper, unsupervised classification, AI based and all. So there is not a certain, we cannot say that this method is particularly better for the crop classification, because we have tried here in the Nextech all the techniques and the algorithms such as spectral angle mapper, artificial neural, maximum likelihood, and all the methods, but we cannot say that this method is particularly best for the crop classification. It basically depends on the availability of data set and the sort of data.
Dr. Juhi, this question, which is the best way to choose the LDU-LC question, is raised by one of the faculty. So I think we give the rights to Dr. Raju so that he can directly ask any question if you have any question to.
Yeah, ma'am. We have all the emails and contact addresses. If sir is not able to join again, we can just share that with all our faculty. That's okay.
Well, I think you are giving the response or answer of this question, which is the better way to choose the LULC classification data on different types of crops for Indian region.
Sorry, ma'am.
Sir, this question is already in the chat box. Which is the better way to choose the LULC classification data on different types of crops for Indian region?
Ma'am, different type of.
Different types of crops for Indian region.
Mr. Renu ma'am's voice is cutting as well. So can you just do it? I think your network.
May I repeat the question?
Yes, ma'am. Yes, ma'am. Please.
Yeah, sir, which is the better way to choose LULC classification data on different types of crops for Indian region?
Basically, ma'am, if we see for the classification of crops, hyperspectral data is one of the best data set, but it is rarely available as the US government has earlier launched a website, Earth Observation website, which the sensor hyperspectral sensor, which comprises the number of bands approximately 223, but it is currently decommissioned and is not available. And in unavailability of the hyperspectral center, we can use the multispectral data set for the classification of land use, land cover, and the crop suitability. And Sentinel-2 2 of the European Space Agency is one of the best data set for land use, land cover classification and crop identification in the various conditions, whether it is India or in any other country.
So fourth question I have, any policies that are effective in promoting climate resilient agricultural practices? So is there any policy? Again.
Yes, ma'am. Hello.
Yes, sir. Am I audible?
Yes,
sir?
ma'am. You are audible. Yes, ma'am.
Yeah. So the fourth question is like, any policies that are effective in promoting climate resilient agricultural practices?
Yes, ma'am. Ma'am, basically, as we can see that, for example, in state of Punjab, the cropping pattern is generally monotonous. They practice the cultivation of paddy during the Kharif season and the mustard and wheat during the in the Rabi season. So basically, we can use the crop rotational method more and more, and the use of mulching for the avoid the soil from depleting, since studies has shown that the monocropping pattern of the area has significantly depleted not only the soil resources but also significantly depleted the water resources of the area. And it is predicted that in the long run the region will be the productivity of the region will go suitability low and will not yield as much as it is providing the food production in the current time period also.
Yes, sir. Thank you so much, sir, for the enlightening us with your knowledge, sir.
Thank you very much, ma'am.
We don't have to engage in grand, heroic action to participate in change. Small acts, when multiplied by millions of people, can transform the world. Moving ahead, the next speaker of the day is Dr. Achelal Yadav. Sir is working as Indian Agricultural Research Institute, New Delhi, as a senior scientist since May 2012 till date. He has executed several projects, including soil and crop health monitoring through sensing, modeling, and big data analytics for resource-efficient, smart agriculture at field to regional scale, risk assessment and management of hydroclimatic hazards on natural resource degradation and agricultural sustainability, assessment and mitigation of greenhouse gas emission, air pollution in agriculture under current and future climatic conditions. Currently, Sir is working on abiotic stress management in crops through application of green nanoparticles. Sir has published more than 20 research papers in various national and international journals. Dear guests and participants, please join us in giving a heartfelt digital greeting to our distinguished speaker as we offer this meaningful virtual Tulsi plant presented by Dr. Please change. Dr. Anamika Srivastava, a symbol of the cultivation and nurturing of wisdom and knowledge in our online gathering today. Welcome, sir. Welcome, sir.
Thank you very much for first of all, I would like to thank you all and your associates for inviting me to have a lecture on green technology related aspects. I thank you also, Juhi, which is my batchmate in PhD at JNU Jawaharlal Nehru University. We have done a PhD together only, and we finished also within the timeline. And then I will share my presentation first.
Welcome, sir, to MET.
Okay.
Seeing after a very long period.
Okay, thank you. My slide is visible, all?
Yes, sir. It's
Yes.
visible.
Okay, once again, thank you very much. Today, my topic will be the synthesis characterization of zinc oxide and ferric oxide nanoparticles, their characterization and application in crops. As the previous speaker told about the climate mitigation and other abiotic stress management, then it is also one of the tool by the application of that we can minimize the abiotic stresses effects on crops. So in this particular aspect, I am working since 2 years. Then first we should know that what is nanotechnology. So all of us know that any material which is having scaling from 1 nanometer to 100 nanometer, any dimension, that is called nano technology, or that particular material is in nano scale. And it is having the multi uses in crops because of the increasing surface area, or we can say volume to surface ratio, and its durability by the way of slow release in soils as well as in leaves of crops. And it is having also a very good biocompatibility, and we can say very less leaching is there because of reduced evaporation as compared to other fertilizers what we are most of the time using in crops like zinc sulfate. Even people are talking about the nano urea that also minimizes the greenhouse gas emissions. Then and most of the nanoparticles in the form of fertilizers are being used, like zinc oxide nanoparticle and the ferric oxide nanoparticles, titanium dioxide nanoparticles, and other nanoparticles are also in use in today's scenario. But mainly zinc oxide and ferric oxide, titanium are mostly being used in the crops. Because the zinc and iron both are very deficient in most of the grains of crops in across the world, and in our we can say in Asian countries about 13% people are suffering with the malnutrition of the zinc and iron. Basically, the pregnant ladies and kids are suffering with the deficiency of iron, and that causes the anemia type of diseases in our developing nations. Keeping these things in view, we are doing some efforts to improve upon the bioavailability or the biofortification of zinc and iron in crop grains, and it's also somewhat useful in reducing the soil and water pollution, because in the use of by the use of the nano fertilizers or nano formulations, the leaching is very less, and the evaporation in the form of gases is also reduced. Then its value of the environmental pollution goes down. Then there are different methods to synthesize the nanoparticles. Some of the green methods and chemical methods are there. A very large number of methods are available nowadays, and that are also cheap for the production. We have synthesized zinc oxide nanoparticles by the way of using aloe vera, and that second one was the skin of Arjuna plant. In this particular aloe vera synthesis, we have taken 99% purity of sodium hydroxide pellets and mixed with the zinc nitrate by the 250 gram of the thoroughly washed aloe vera gel, and we also and then a portion was of its portion extracted from the aloe vera and cast in ground to thin paste by adding enough ionized water. And then the resulting extract was stored at 10 degrees centigrade for further experiments, and the latter zinc nitrate was dissolved in the aloe extract and solution under the constant stirring. All these were methods for, and these methods are available in net also. No need to read all these things. Then the chemical method was also we tried and synthesized the zinc and ferric oxide nanoparticles, and then characterized these powders, how we got it. Then first was the zinc oxide nanoparticles. For that only we run this powder, make a solution of 2 ppm, and got one absorbance graph for it. And this is, you can see here is a peak around 379 nanometer, and that indicates that the zinc oxide zinc was available there. And also we characterized these zinc oxide nanoparticles through transverse electron microscopy. First, I would like to tell how the microscopy can be used in the characterization or measuring the size of the nanoparticles. As we know that we are having the optical microscopy as well as electron-based microscopy. In the optical microscopy, we cannot change the wavelength because the resolving power of any microscope depends on its wavelength and numerical aperture. The wavelength can just, that is lambda equal to h by 2 mu sin alpha, and slow denominator, that is numerical aperture, and in denominator that is wavelength. That cannot be changed in optical instruments, optical microscopy, but in electron microscopy we can change or reduce the wavelength so that our the value of resolution R will be reduced. Resolution means the two things which can be seen separately most closely. If we can see those things with a optical or any equipment, then its resolution will be very high. So for that only we can use the electron microscope. The electron microscope, in what happens in electron microscope, we are using the electron beam in place of light, and electron beam can be given any speed by the way of the increasing the voltage, and we can reduce lambda that's de Broglie wavelength, lambda equal to h by p, where p is nothing but say 2 MeV square root. Then if you are increasing the wave voltage, then the wavelength will go down, and ultimately the resolution of that electron microscopy will go up. So for that purpose, in the research of nanotechnology, we are using the electron microscopy. Then we are also using the atomic force microscopy, and atomic force microscopy is based on the tunneling. It's not a touching effect. One cantilever is there, and that is moving on the surface, and that on the basis of undulation, that gives the electrical impulses, and those impulses give you the size of the particles, which size of the particles are there. So we have run those prepared samples through TEM, transverse electron microscopy, and we got the size of those nanoparticles around 14 to 15 nanometers of the zinc oxide nanoparticles. Then in the second form, we have tested the ferric oxide nanoparticles, which is synthesized by the way of the chemical method, and we firstly tested the presence of ferric oxide nanoparticles via the UV visible spectroscopy, and we got its peak at 249 nanometers. That was confirmed that the observer the ferric oxide nanoparticles material is there. And similarly to zinc oxide nanoparticles, we run these samples in transverse electron microscope, and we got again the size of nanoparticles around 12 nanometers. Then after synthesizing and characterization, we use these nanoparticles in crops, and I would like to share here what are the modes of application of nanoparticles in crops. There are two ways to apply the nanoparticles in crops. First one is foliar application, and second one is the soil application. In the, am I audible you? Hello?
Yes, sir. Yes, sir. You
Okay,
are
sorry.
audible, sir.
Yes, sir, you're audible, sir.
Okay. And then so there are two modes of the application of nanoparticles. First, we can use by the foliar application, which is more suitable than the soil application. And then what happens? Most of the pore sizes of the crop plants are in the size of nanoparticles around 20 to 50 nanometers. And if we are giving the application of the nano fertilizers solution, and through foliar application, that is more effective than the soil. And similarly, we can, but before putting the before apply, we should make the solution of the zinc oxide, any nanoparticles with the sonicator, so that it can be properly mixed and spray within 2 or 3 hours, so that agglomeration should not be there. The same way we can use also in the soil, and the plants take these fertilizers and through the hair type very fine roots, and ultimately that affects the photosynthetic rate. And that's we know that what is the photosynthetic rate. That photosynthetic rate that's converts happen in the presence of light, carbon dioxide, and water, and then it converts to the this radiation into the form of starch, and ultimately the carbohydrate, and that is called the biomass, and that is related with the productivity. But here this is the application of zinc oxide or ferric oxide nanoparticles increase the quality or biofortification of zinc and iron. So for that only we have tried first the zinc oxide nanoparticles application, in which how we have given this treatment to the wheat. We prepared the solutions of the 20 mg and 25 mg per kg and 30 mg per kg type of solutions. We can say in form of ppm, and similarly we also given the equivalent amount of the zinc sulfate and compared that which type of fertilizer is performing better. Then we could see from here that the seedling vigor and the seedling vigor, that's an indication of the first growth of the crop seedlings. That indicates that's product of germination into the seedling length. If the seedling length first of all is better, then ultimately the crop perform better, will be better. So we could see here that the seedling vigor was highly significantly better under the 25 mg kg zinc oxide nanoparticle treatment as compared to the zinc sulfate. And then we also estimated or determined the photosynthetic rate at the stage of flowering of the wheat crop. That was HD 2967. That was the variety of the wheat. And we could see here that with the application of zinc oxide and zinc sulfate also, the photosynthetic rate was increased, but it was significantly more under the zinc oxide nanoparticles as compared to its counterpart fertilizer zinc sulfate. In this, you can see in this figures that how the zinc oxide nanoparticles and zinc sulfate affected the stomatal conductance. Stomatal conductance is also very much important in terms of the evapotranspiration, and that was also indicating the crop growth. And then crop growth was maximum at the second or 20 mg per kg treatment of that soil, as the photosynthetic rate was higher in the same treatment. And then tillers means the branches of the crop per plant, and that was also maximum under the same treatment. And this also contributing ultimately in the crop yield and biomass. Then spike length means length of spikes, and the spikelets both were not significantly changed across the treatments. Both were similar, but they were somewhat better under the 20 mg 20 ppm treatment of the soil, but they were not significantly different in all 6 treatments. Here 6 treatments means two treatment was control and 2 treatment for the zinc, one zinc oxide nanoparticles and second one for zinc sulfate. Then it becomes 6 treatments, but here 1, 2, 3, 4, 5, 6 like that. Then we also estimated the grain weight per spike. That was a very specific parameter for that, and we could see here the grain weight per spike was notably higher under the 20 mg per kg treatment, but the 1000 grade weight was not differed across the treatment. They were almost similar to each other, but the grain weight was per spike was notably higher, and that will also contributed in the increased yield of the crop. And here we could see the biomass, grain yield, and zinc concentration. Then biomass means the overall weight of the crop plant it includes the stem grain or above biomass, above ground biomass. That was maximum under the 25 mg/kg treatment of the soil. And similarly, we could see from here that the grain yield of that the second treatment or 25 mg per kg treatment was the best, better. So one aim we achieved that the treatment of the zinc oxide nanoparticles as compared to the conventional fertilizer, zinc sulfate, perform better notably, and the ultimately aim was to see that whether the zinc biofortification is increasing in grains or not. Then we could see that the zinc concentration in grains increase with the treatments, and it was maximum at the 20 mg per kg treatment of the soil. That indicates the zinc biofortification in grains is happening by the use of zinc oxide nanoparticles as the conventional fertilizer zinc sulfate. Then we also tried the application of zinc oxide nanoparticles under the TGT temperature gradient tunnel. Whether our hypothesis was there that whether there is any change on the production and productivity of the grain yield of wheat under the high temperature or increasing temperature stays 1 degree centigrade. For that, we conducted one experiment under the temperature gradient tunnel. I think you must have seen that temperature gradient tunnel. We are making that type of tunnel to increase the temperature. I should have given some figure, but I did not give. Sorry for that. And this temperature was almost 1 degree more. Average temperature was 1 degree more across the growing season. And we could see there here this the six treatments were there. First one is the ambient treatment that was outside, and the T2 was the inside, and T3 was a zinc oxide nanoparticle treatment that was 20 mg per kg, and this T4 was 25 mg per kg, and T6 was for the zinc sulfate equivalent to T3, and the T6 was that the equivalent to T4. And we compare these results that the grain weight per spike was better under the zinc oxide nanoparticle treated pots. The whole the study was conducted in pots only, because that we have there, like this is very precise type of experimentation. At the field level, we can do, but for initially we should we conducted in pots only, and we could see here from that the grain yield was again a maximum under the gene treatments, and the control treatment was significantly lesser than the zinc treated soils. It indicates that the zinc oxide nanoparticles application is having the capability to mitigate the temperature stress or this abiotic stress of heat. We can minimize this proper application of the zinc oxide nanoparticles is given. That's also one of the major findings in our experiment. Then we use the zinc oxide nanoparticles and ferric oxide nanoparticles on soybean crop. How does the soybean crop is responding to the different type of combination of zinc oxide nanoparticles and ferric oxide nanoparticles, and their counterpart zinc sulfate and ferric sulfate type of conventional fertilizers. So these were the planning of the experiment. We have given 7 treatments First one was control, second one was zinc oxide nanoparticles, and third one was the ferric oxide nanoparticles, and then fourth was the combination of zinc oxide nanoparticles and ferric oxide nanoparticles, and then remaining three were from their conventional counterpart, conventional fertilizers. Then we could see that the photosynthetic rate was maximum under the interactive condition of zinc oxide and ferric oxide nanoparticles as compared to the other treatments. But in this case also, the ferric sulfate and zinc sulfate interaction have also the significant enhancement in the photosynthetic rate. And then photosynthetic rate ultimately results into the better production and productivity of crops. In NDVI, we estimated NDVI, normalized difference vegetation index, that depends on the canopy cover of the crop, and that's, if it is more, then NDVI will be more. It goes up to 1, 0 to 1, and we could see here the interactive condition of the nanoparticles shown significantly better, although the interactive condition of the zinc and ferrous sulfate was more, but not significantly different from the control. Then SPAD values, SPAD is directly again the indicator of the photosynthetic rate. It was somewhat more under the interactive condition, but not significantly different across the treatment of the two varieties of soybean crops. We took two varieties, that was SL 958 and PS 1347. Both are very much popular varieties across India of the soybean. Then we also estimated the number of grains per plant, how the number of grains per plant was increasing or decreasing with treatments. Then we could see here again that the interactive condition of zinc oxide nanoparticles as well as the interactive condition of the zinc sulfate and iron sulfate perform better in both the variety. That was better in the interactive condition of the zinc oxide and ferric oxide nanoparticles, but here only one variety responded positively to the number of grains per plant. And then test weight, it's a genetically almost a fish type of character of the any crop variety. That may be the reason it is not changing. If a crop is not under stress of temperature, or we can say of water, then it will be almost similar. And then we again estimated the biomass and grain yield, and we could see that similar to our photosynthetic rate, the biomass and the grain yield both perform significantly better as compared to other treatments what we have given in the form of the zinc oxide, ferric oxide, and zinc sulfate and ferrous sulfate, as well as control. Here we have compared all the parameters with the control treatment, that is T1. And also, if you compare, that's one reason was there. Here both are looking the similar, but if you compare the interactive condition of zinc oxide and ferric oxide nanoparticles with their counterpart conventional fertilizers, then you see that the grain yield per plant also increased 11 to 26% under the T2 than T7, means the interactive condition of the zinc oxide and ferric oxide nanoparticles perform better than interactive condition of the zinc oxide and ferric oxide nanoparticles. Significantly, it is around 11 to 26%. Then we estimated the oil content of the soybean, because soybean also a good source of oil, and we could not see much effect or significant effect under the zinc oxide nanoparticles and their interactive conditions in both the conventional as well as the nano fertilization, and it was varying from 14.5 to around 16.3%. And we estimated the again iron and zinc concentration in the grains, because other parts we did not estimated it, but we have estimated in grains, and we could see from here that the zinc concentration in grain was increased almost 250% as compared to the control. It was also more under the interactive condition of zinc and iron oxide nanoparticles as well as zinc sulfate, but it was much higher in the single zinc oxide nanoparticles. It means the zinc oxide nanoparticles were directly influencing the zinc concentration or zinc biofortification in the grains. And the phytic acid content, which is the anti-nutritional factor in the grains, which adversely affects the availability of any nutritional value in the grains. And we got it that the zinc, the phytic acid concentration was minimum in the zinc and iron oxide nanoparticle application. That was around 30% as compared to the control, and similarly, but it was higher under the interactive condition of the zinc oxide and ferric oxide nanoparticles, as well as the zinc sulfate and ferric sulfate ferric sulfate conventional fertilizers. That one may be the reason that the phytic acid is always negative charge, and the zinc and iron both are having the positive charge, and that because of the attraction to each at the level of the movement from soil to grain level, and that may be the reason to reducing the concentration of phytic acid in grains of the soybean crops. Then we also conducted one experiment under free air temperature enrichment facility to assess the effect of zinc oxide nanoparticles on under heat stress. We conducted that experiment with one variety of the rice, that was Pusa Basmati 1, and we could see that the spike biomass was ambient means this treatment was outside of FATE. FATE means free air temperature enrichment facility, and it was outside, and this ETCK means it was a elevated temperature under the FATE, and these were the zinc oxide nanoparticle treatments in 2 treatments under the FATE condition, and again the same equivalent to same quantity of zinc in the zinc sulfate, and we could see there that it is not significantly more, but it was better under the treatment of zinc oxide nanoparticles. And similarly, we could see here that the grain yield per spike means the total grains weight, what we got in that one spike, average of at least 20 spikes, that was better under the zinc oxide nanoparticles treated soil. We also estimated the 100 grain weight. Then 100 grain weight was far better than this temperature control under the elevated temperature condition, and that was at par with the ambient. It means that the application of zinc oxide nanoparticles can mitigate the stress condition of temperature in rice, also in the grain size and great grain fulfilling conditions. And then finally we calculated the grain yield. Grain yield per hill. Per hill means what number of how to at a time of transplanting. Suppose that we are taking 2 plants at a time for 1 plant and converting into 1 plant means 2 seedlings for 1 plant. That is called grain yield. It is not fixed. It may be 2, it may be 3 also, but that particular combination of 2 or 3 plants or seedlings in 1 plant is called hill. Then we could see that that was also performing better under the zinc oxide nanoparticle treated soils as compared to zinc sulfate treatments, and they were at par with the control. It means the zinc oxide nanoparticles are having the mitigative capability, or can mitigate also the adverse effect of elevated temperature. That is drastically means if temperature is increasing at the time of flowering, then the production of rice goes down by 10 to 15% or up to 10% of rice crop. So that can be mitigated with the application of zinc oxide nanoparticles. Then we have also tried the various size zinc oxide nanoparticles on rice, and we could see we have taken the 2 varieties and 7 treatments, 8 treatments, and we had 3 size of nanoparticles. First one is 30 nanometer, second one was the 40 nanometers, and third was 90 nanometers, and equivalent the conventional fertilizers. And we could see that the smallest one nanoparticles have performed better, almost in the case of spread value as well as the plant height. And we also estimated the regions of the effect of positive effect of the zinc and zinc oxide nanoparticles. For that, we estimated the catalase. That's also a type of enzyme which is responsible for the positive change of application of zinc oxide nanoparticles in any crop. And we tried for the rice, and we could see that the zinc oxide nanoparticles application perform better, although zinc sulfate and others perform in the similar way, but ultimately they perform better in the zinc oxide 30 nanometers plus foliar application. This one we have here given the zinc oxide nanoparticles in soil and soil plus foliar, which up to here this was zinc oxide nanoparticles application in soil, and then zinc oxide nanoparticles application soil plus foliar. You can see here, and we give only the zinc sulfate here equivalent to the zinc oxide nanoparticles. Only 1 dose, 1 treatment that was there, and this was the control without any application. So you can see here that the zinc oxide nanoparticles applications in soil and soil plus foliar both perform better as compared to the control and this counterpart application of zinc sulfate. In the case of catalase and sodium dioxide also, that's called sod, and that's are also antioxidant elements of crops. SOD, proline, and catalase to be here estimated catalase and SOD2. Then we estimated the tillers. Tillers means number of branches in each treatment, and we could see these two treatments were almost non-significant are lesser than all these other treatments. In the case of grain yield also, as well as in tillers, because the tillers also ultimately affect the value of the grain yield, etc. Then we estimated the zinc concentration, and then zinc concentration was also similar to other crops. It was drastically higher in the zinc oxide nanoparticles, plus zinc plus Fourier application, and they were highly significant as to compare to control and the equivalent zinc sulfate treated soils. And this phytic acid was again reduced, as I told you, the reason why the phytic acid concentration was minimum under the treatment of the zinc as well as zinc plus foliar applications, and it means that the anti-nuclear value is also going down with the application of zinc oxide nanoparticles. So with this, thank you very much for giving me opportunity to interact with you, the various application of zinc oxide and ferric oxide nanoparticles in different crops. Thank you.
Thank you. Thank you so much, sir, for such an enlightening session. Sir, we have few questions from our participants.
Oh, yes.
Yes, sir. Sir, are there environmental considerations and
Yes,
safety aspects associated with their use in crop management system?
Yes, ma'am.
Sir, are there environmental considerations and safety aspects associated with their use in crop management system? So this is regarding the nanoparticle use in the agriculture system.
That is there. DBT is having some guidelines for using the nanoparticles, and some certain concentrations it is allowed to use it. Like that in research, it is going on 1 ppm to 200, 300 ppm level, but we used only up to 25 ppm level. That is optimum level, and that is coming within that range.
Okay, sir. Sir, another question also related to nanoparticle.
Yeah,
How
yeah.
can these nanoparticles affect the agricultural infrastructure, such as irrigation systems and storage facilities?
Actually, in the case of storage, research may be taken up, but right till now I have not seen any research paper on that basis. But the irrigation, it is definitely, if drought stress is there, our next target is there to how to minimize the stress of drought tolerance. How to increase the drought tolerance by the way of using of zinc oxide or any type of nanoparticles, because these nanoparticles are associated with the photosynthetic rate, and ultimately photosynthetic rate determines each and everything on crops. So this we are planning to that one. We also started one experiment on mung bean to give 40% reduced irrigation of the water field capacity. Field capacity means suppose that 40%, 100% is there, then we will reduce by 50% and test the efficacy of nanoparticles on that. So that is also there, and it is being, one research paper was published in Science of Total Environment on the pearl millet before 2 or 3 years, that they have given some reduced water or water stress. You are talking about it, Malina. So water stress, and then application of zinc oxide nanoparticles, and they got the better results in application of zinc oxide nanoparticles.
Yes, sir. Thank you. Thank you so much, sir.
Any other question also?
No, sir. Thank you, sir. Just Dr. Renu Thopar is connecting.
जूही मैडम किधर गई?
Joy madam is also there, sir.
यहीं पे है सर, यहीं पे.
हाँ, आप भी पूछिए ना कुछ. नहीं, आपको अच्छा नहीं लगा लगता है.
नहीं सर, मैंने आपसे क्वेश्चन पूछा है. एक क्वेश्चन मेरा ही था इनमें से.
अच्छा. मैं इसको मिनिमाइज कर दूं. ये बाहर आ जाऊं?
सर स्क्रीन शेयर बंद कर दीजिए।
ओके ओके।
सर एक और छोटा सा क्वेश्चन है, ये
यस हाँ, बोलिए मैडम।
जो नैनो पार्टिकल्स यूज करते हैं क्रॉप के लिए, एप्लीकेशन के लिए,
कहाँ से जाएगा, ये जा नहीं रहा।
सर ऊपर, हाँ हो गया,
हाँ,
हो गया। जो हम नैनो पार्टिकल्स यूज करते हैं क्रॉप एप्लीकेशन में,
हाँ।
ये इकोनॉमिकली सस्टेनेबल है? मतलब इसे
एक्चुअली
पैसे
में
की दिक्कत तो नहीं?
यदि आप ग्रीन नैनो पार्टिकल्स करते हो तो बहुत चीप है ये, हैं? आप प्लांट मटेरियल कुछ भी लीजिए, उसमें जिंक नाइट्रेट मिलाइए और NaOH का एक pH मेंटेन करने के लिए we will have to give it, and you can produce it in between. You will have to characterize at least by UV visible or some TEM or SEM, so that you will be confident the size is within the nano range. You can do it, and it will be cheaper in green synthesis of nanoparticles, and eco-friendly also.
ओके, ठीक है सर, थैंक यू।
हाँ,
एक्चुअली मेजोरिटी टाइम में रिसर्च में ये बहुत बड़ा इशू रहता है ना, कि जो कर रहे हैं वो एप्लीकेशन ऑन ग्राउंड आ पाएगी कि नहीं, और पैसे
नहीं,
उसमें
actually
बहुत
में
बड़ा फैक्टर रहता है।
इसमें क्या होता है जी, आपको क्वांटिटी बहुत कम लेनी पड़ती है। सपोज दैट आप देखो जिंक सल्फेट लोगे 1 बोरी, तो इसमें उसका 10% लेना है आपको, है? और आप फोलियर एप्लीकेशन करते हो तो और कम लेना है, 20 ppm का बनाइए। 20 ppm मतलब 1 लीटर, मान लीजिए 10 लीटर 1 हेक्टेयर में लगता है, तो 20 ppm का कितना हो जाएगा? 20 ppm मैंने कितना 200 ग्राम से भी कम नीचे आएगा ना, 220 ग्राम्स है। तो दैट मच यू कैन, but preparation should be proper. That should be in nano size. Agglomeration should not be there. At some precautions should we will have to take. Otherwise, agglomeration is a problem in nanomaterials. Then it will be very cheaper. And the biofortification is also very good in that case. Zinc is a problem in nutrition. Iron is a problem in nutrition. That it can be increased
फोर्टिफिकेशन
by
के
the
लिए
way
भी
of
हेल्प कर जाएंगे।
agronomic practices. If you are going through the genetics, then you will have to modify at the molecule level. That's research may be going on, that I don't know. But agronomical practices in growing crops and Fourier application and soil application, that is going on.
आई गेट, ठीक है सर, थैंक यू।
Okay. Bye bye.
थैंक यू
कभी
सर।
फिर IRA घूम जाइए ना। हेलो।
यस सर, बिल्कुल, आप कॉन्फ्रेंस करवाइए, कॉन्फ्रेंस कराएंगे, हम भी इसी चीज में आएंगे।
हमारे कॉन्फ्रेंस के लिए तो गवर्नमेंट पैसे नहीं
रेनू
देती
मैम
हमको।
रेनू मैम शायद अभी अवेलेबल नहीं है, अदरवाइज रेनू मैम से बोलते हैं हम, रेनू मैम बोलती हैं आपको, फिर आप कॉन्फ्रेंस कराते हैं, फिर हम सारे आते हैं।
अच्छा, रेनू मैम को तो मैं जानता हूँ, MIT वाली ना, वो डायरेक्टर है आपकी ना।
यस सर, हमारी अभी
हाँ
डिपार्टमेंट की, हाँ हाँ जी, हाँ
हाँ
जी।
हाँ, अच्छा अच्छा अच्छा, आई नो हर मेट आल्सो 1 or 2 times। ठीक है,
ठीक है सर, ठीक है सर, थैंक यू।
ठीक है, ओके। तो मैं अब लीव करूँ?
सर बैकग्राउंड में कनेक्टेड रहना तो रहिए, अदरवाइज
अच्छा,
आपका।
हाँ ठीक
हाँ
है,
जी सर, एक्चुअली हम डॉक्यूमेंट्री प्ले करेंगे अब।
ओके ठीक। तो ये इट इज कंट्रोल बाय यू ओनली ना, आई कैन नॉट डू एनीथिंग।
हाँ सर, आपको जरूरत नहीं है, बैकग्राउंड में बस आप अपना कैमरा ऑफ करके रह सकते हैं, या फिर
ठीक
जैसा
है,
आपको ठीक लगे।
ओके।
Miss Richa, I think we can proceed further with the documentary announcement.
Yes, ma'am. Sustainability
Yeah.
is about meeting the needs of the present without compromising the ability of future generations to meet their own needs. Ladies and gentlemen, as we gather here today to discuss sustainable agriculture and infrastructure, it is imperative to also focus on the lungs of our planet, that is our forest. In just a few moments, we will be screening a compelling documentary that dwells into the intricate relationships between forest and sustainable living. This feature not only educates us about the ecological significance of forests, but also explores how they directly impact agriculture and infrastructure. Let's open our minds and hearts to understand how we can coexist with these natural wonders to create a sustainable future. Thank you, and please join the documentary. Is it visible, ma'am?
Sir, did you share the sound as well? Because I'm not able
Yeah,
to hear any
Is
sound.
it okay, ma'am? No?
No, the sound is not audible right now.
Mine?
Ma'am, now is it audible also?
No, Richa, it's not. Richa, I think you have not shared sound on this. तो आपको दोबारा टॉप शेयर करके रीशेयर करो और रीशेयर करने पे व्हेन यू चूज द विंडो कि आप कौन सी शेयर कर रहे हो उसके नीचे ही एक बॉक्स में लिखा होगा शेयर साउंड, तो आप वहां से शेयर साउंड करके फिर अपनी विंडो शेयर करोगे तब साउंड सुनाई देगी.
Okay, ma'am.
Since then,
Is it?
the human population
It is. और पीछे करके एक बार स्टार्टिंग कर दो.
we finally ventured to the moon. However,
You're audible, Richa. I think we can proceed with the formal vote of thanks.
Yeah, I have shared the assessment link in the chat box. Kindly go through it.
Everyone, please complete the assessment by today itself. Everyone would be provided with the participatory certificates only on the basis of this evaluation.
Sustainability is a journey, not a destination. We must constantly strive to do better, to be better stewards of the earth and all its inhabitants. Moving ahead, it is with a deep sense of gratitude and satisfaction that I stand before you to offer a heartfelt vote of thanks for gracing the third session of the certificate course on green technology for mitigating climate change, organized by AIES in a hybrid mode in collaboration with India Meteorological Department, New Delhi, and leads Next Tech India Private Limited. This event marks the beginning of a transformative journey towards understanding and addressing the pressing issue of climate change through the lens of innovative green technology. At the outset, I, on behalf of AIES, would like to convey my deep regards and hearty thanks to Honorable Founder President Dr. Ashok Kumar Chauhan sir and the Chancellor Amity University Uttar Pradesh, Dr. Atul Chauhan sir, for their continuous guidance and encouragement. It is their vision and leadership that has placed Amity University among the top universities in the world. Our heartfelt thanks goes to the Professor Dr. Balwinder Shukla, Vice Chancellor of Amity University, Uttar Pradesh, for her visionary leadership and commitment to academic excellence. She has been guiding and motivational force for all of us. We would like to express our sincere appreciation to Professor Dr. D.K. Bandyopadhyay sir, Chief Advisory, FPO, Chairman of Amity Law School, and mentor of Amity Institute of Environmental Sciences for your enlightening address. Your expertise in the field has brought a unique perspective to our discussions, and we are truly grateful for your valuable contribution. We extend our sincere appreciation to Dr. Renu Duper, Assistant Director, AIES, for providing us with an insightful introduction to the 1-month certificate course. Your words have set the tone for the event, and we are grateful for your valuable contribution. We are truly honored and privileged to have Dr. K. Karthikeyan, Dr. Amar Kumar, and Dr. Achilal Yadav join us today as the distinguished guest of honor for the third session of 1-month certificate course on sustainable agriculture and green infrastructure. Their presence has added immense value and significance to our gathering, and we are deeply grateful for the time and insights they have shared with us. Their expertise and wisdom have not only enriched us personally, but have also provided us with a broader perspective on the themes. We also extend our sincere gratitude to the India Meteorological Department, New Delhi, and Leeds Next Tech India Private Limited for their invaluable collaboration in making this course a reality. Your expertise, support, and dedication have played a vital role in shaping the foundation of this learning endeavor. Our esteemed faculty members, experts, and resource persons and staffs we thank you for your willingness to guide and inspire our participants throughout this journey. Your insights and commitment to sharing knowledge will undoubtedly shape a new generation of environmentally conscious leaders. To our participants, your presence signifies your dedication to advancing knowledge and taking a step toward a more sustainable future. I especially thank to the people who have been the backbone of the event, the IT and media team of Amity, the team who has worked tirelessly behind the scenes to ensure the smooth organization of this course. Your dedication and attention to detail have not gone unnoticed. Lastly, I would like to express my sincere thanks to each one of you present here today. As we journey forward, let us remember that the impact of this course extends beyond these walls. The knowledge gained, insights shared, and connection forged will contribute to a more sustainable future for all. Let us embrace this opportunity to make a difference and collectively work towards mitigating climate change. Thank you once again, and let us eagerly anticipate the transformative learning experiences that lie ahead. Thank you so much.